Welcome to this essential guide on ORM misuse exploitation, commonly known as ORM injection. This represents a critical vulnerability that developers and security professionals need to master to safeguard their database-driven applications effectively. Object-relational mappers, or ORMs, serve as powerful tools designed to bridge the gap between object-oriented programming languages like Python and relational databases, such as PostgreSQL or MySQL. They enable developers to interact with databases using intuitive programming language constructs, eliminating the need for writing raw SQL statements and thereby simplifying complex data operations like querying and updating records. However, ORM injection happens when an attacker cleverly manipulates user input to deceive the ORM into generating unintended and highly malicious database queries that can compromise the entire system. This vulnerability typically arises in applications that directly incorporate untrusted user input into ORM queries without implementing proper sanitization techniques or parameterization methods. Skilled attackers can exploit this flaw to bypass authentication mechanisms, extract sensitive user data, or even modify and delete critical database records, leading to severe data breaches. To grasp how this exploitation unfolds in real-world scenarios, let's closely examine a common vulnerable code example from a typical development environment. Imagine a Python web application leveraging SQL Alchemy, where a user's input is directly used to filter database records without any proper escaping or validation procedures in place. For instance, a legitimate user might simply input their username like Alice to retrieve their personal profile information securely from the database. In contrast, a malicious actor could craft a dangerous string such as admin or 1 equals 1 and input it to attempt bypassing the authentication process entirely. Unaware of the attacker's malicious intent, the ORM seamlessly incorporates this tainted input directly into the generated query, resulting in a highly unintended and dangerous SQL statement. This malicious input effectively transforms the ORM-generated query into a harmful statement like select asterisk from users where username equals admin or 1 equals 1, exposing the database. The injected 1 equals 1 condition is a tautology that always evaluates to true, thereby bypassing the original username check and granting unauthorized access to the attacker. The key to preventing ORM injection lies primarily in adopting parameterized queries or prepared statements within your ORM configurations. Fortunately, most modern ORMs, including SQL Alchemy, offer robust built-in mechanisms for safe parameter handling that treat all user inputs strictly as data rather than executable code. It's imperative to always validate and sanitize every piece of user input on the server side, regardless of any client-side validation that might already be implemented for usability. Furthermore, conducting regular security audits and thorough code reviews remains crucial for proactively identifying and remediating any lurking ORM injection vulnerabilities in your codebase. By fully understanding these concepts and diligently implementing these proven preventative measures, developers can dramatically enhance the overall security posture of their applications against sophisticated ORM injection attacks.